Evaluate the line integral. Where C is a line segment from 1, 3 to 2, 6. First, let's parameterize this. So we're going to have R of t. And you always want to start with this point here. So it'll be 1 comma 3. And then plus t times the difference of these 2 points. So do 2 minus 1 and then 6 minus 3. Then we can rewrite this as 1 plus t comma 3 plus 3t. Basically, you're just going to be adding the x's and then the y's. Don't forget, you always have to multiply this part by t. Alright, since we found r of t, let's also find r prime of t. That's going to be 1 comma 3. Next step, we want to find f of r of t. F is 5x to the 4th, so we're going to replace x with x of t, which is 1 plus t. Right, this is the x of t, and this is the y of t. And finally, we need ds. ds will be the length of the derivative, so the vector, which will be 1 squared plus 3 squared, and that's the square root of 10. Finally, we could just multiply these and then take the integral. Well, notice if t is 0, we get 1, 3. If t is 1, we get 2, 6, based off this r of t parameterization. So that means we're going from 0 to 1, 5 times 1 plus t to the 4th times root 10 dt. Integrate this, we get 1 plus t to the 5th, and we'll put root 10 in front, and then we have to go from 0 to 1. That's 32 root 10 minus root 10, which is 31 root 10. Find the work done by the force field F of x, y, z equals xi plus yj plus 4zk on a particle as it moves along the path c. R of t is 2 cosine t I plus 2 sine tj plus tk. And here we're given that t is between 0 and 2 pi. So first let's find the derivative of r of t. So that's negative 2 sine ti plus 2 cosine tj plus 1k. And then let's find f of r of t. So for this one, we're going to be replacing x, y, and z with x, y, and z. So x was 2 cosine t, y is 2 sine t. And then we have 4z, z is just t. So we have 4tk. And now what we have to do is a dot product of this thing. So we're going to multiply and then add. So first let's multiply the x's. So negative 2 sine t times 2 cosine t. That's negative 4 sine t cosine t. And next we're going to move to 2 cosine t times 2 sine t. So that's 4 sine t cosine t. And then finally we're going to multiply the k's. So here this is just 1k and this is 4t. So if you multiply that you get 4t. Good thing is 4 sine t cosine t gets canceled, and so we're left with 4t. So now this is going to go inside the integral, and we're given t is from 0 to 2 pi. Integrating this, we get 2t squared from 0 to 2 pi, and so this is 8 pi squared. Okay. Last example, we're given f of x, y, z, is 2xy squared I plus parentheses 2yx squared plus 2yj, and we're going from 0, 0, 0 to 3, 1, 1. Okay, so this is going to be another line integral. Okay, so we need to come up with a parametrization, and because this starts at the origin, you could just put 3t, t, and t as r of t, because really you'll be taking 0, 0, 0, adding it with a difference between these 2 points times t. But this is what it is simplified. And so r prime of t is just 3, 1, 1. Next we'll find f of r of t. So this is x, this is y, this is z. Plug it in. Okay, so this is 6t cubed and 2t cubed plus 2t. And there's no k here, so you can think of this as just 0k. So we have now two vectors. Now we would need to find the dot product of these two. So here we'll be multiplying the x's. So it's 3 and 6t cubed. Then multiplying the y's. 1 and 2t cubed plus 2t. And then the k's. 1 and 0. So when we multiply them, so 3 times 6t cubed is 18t cubed. And then 1 times 2t cubed plus 2t is just that. And 1 times 0 is just 0. So this will just be 20t cubed plus 2t. And now we have to put this in here, the integral. We said, well, if t is 0 here, we get the origin. So r of 0 is just 0, 0, 0, 0. And then r of 1 is 3, 1, 1. Okay, so that means we start at 0, end up at 1. So our limits go from 0 to 1. So this will just be 5t to the 4th plus t squared, going from 0 to 1. And that's going to be 6.